Hey, hi, good evening, everyone. Good evening, friends. Right, let's get started. Welcome, everyone, to our 30 days free short term training from Python to AI. Right, we have understood, you know, the CRISP MLQ methodology, and we are actually learning phase 2 of CRISP MLQ. Right, in the last class, we have understood second moment business decision as well as third moment business decision, right? So before we get started for the day, we'll quickly recap from data pre-processing, from data preparation stage. Then we'll dive into the fourth moment business decision. Let's get started, guys. Right, so as part of CRISP MLQ, there are in total 6 phases. In total, there are 6 phases. Out of these 6 phases, the first phase is where we understand the business and the data. Then the second phase is where we prepare the data preparation. The third phase is model building. Fourth phase is model evaluation. Fifth phase is model deployment. And sixth phase is monitoring and maintenance. Right. So first phase, we are going to understand the data, right? Before understanding the data, we have to understand the business problem, the actual problem that the client is actually facing, and then the data that was shared by the client. Post understanding the data characteristics and all, you know, we are supposed to prepare the data for the next phase. So as part of phase 2, there are three subphases. Okay, one is EDA, exploratory data analysis. Then second one is data cleansing. Third one is feature engineering. Right? So under EDA, again, we started learning EDA. So under EDA, there are four moments. First moment, second moment, third moment, and fourth moment, plus data visualization. We are going to visualize the data. So EDA is nothing but it's a analysis, it's a data analysis technique we get using the insights using by calculating all these four moments and visualizing the data. Okay, so we are trying to visualize the raw data that was shared by the client. Perfect. Under four moments, the first moment business decision, it measures or it is a measure of central tendency, which is nothing but it calculates or it represents the center value. We try to understand the representative value using first moment business decision measures. So what are the measures that we have under first moment business decision? Mean, median, mode. What is the formula for mean, friends? What is the formula for mean? Mean is represented using mu. Okay, summation of x by n. Sum of observations by number of observations. Right. So in general, it is nothing but average. So mean will give us the center value, the representative value of our data. But is it in every case? No. If there are outliers, if there are extreme values present in the data, their mean does not help us because mean gets influenced because of these outliers. I will talk about these, in the coming today or tomorrow's class. Okay, what are these outliers? How they are visualized? Everything we are going to discuss. So mean gets influenced because of these outliers. In such cases, okay, we are supposed to consider median value. the middlemost value of an ordered data set, right? So median is the middlemost value of an ordered data set which does not get influenced by outliers. Even though if there are outliers, extreme values, median does not get influenced. Right. What is mode then? Mode is most repeated value, and mode is the only measure throughout the entire EDA process which can be calculated for non-numeric data also. If you go and look out for any other measure, all of the rest of the measures can be calculated only for numeric columns. But mode is the only measure throughout EDA, or I should say entire EDA. It is the only measure that can be calculated for non-numeric data. What does mode help us? In which way is mode value is talking or helping us? If that is the question, if you have clusters, groups. Okay, so it talks about the groups or number of clusters that can be, actually grouped, or data can be grouped. Right. So first moment business decision, it's talking about the center value, the representative value of a data. What about second moment business decision? Second moment business decision is nothing but it's a measure of spread. It's a measure of deviation. It's a measure of dispersion. Okay, from center, spread from center towards, it's actually talking about the spread from the center, and this can be calculated using a measure called variance. What is the formula for variance, friends? Variance. Can someone tell me what is the formula for variance? How variance is represented? Sigma square. Okay, sigma square is equal to summation of x minus mu whole square by n. No. Summation of x minus mu whole square by n. Spread from the center. Okay. In order to ignore that, zero problem that we have for uniform distributed data, we are actually using square in the numerator. Right. So this actually gives us the squared spread. That is a disadvantage of considering variance measure. What if I have to get the original value? I have to go and use standard deviation. Nothing but sigma, which is nothing but square root of variance. So standard deviation gives us the actual spread. Then finally range. Range will be maximum value minus minimum value. Max minus min. Right? So second moment business decision, it's talking about the spread from the center, and this spread can be identified by calculating, variance. But the drawback with variance is it gives us the square spread, so it's always, the good approach or the right approach is calculating standard deviation, which is nothing but the square root of spread. Good. What does third moment business decision measure? Third moment business decision. What does it talk about? Why should we go and calculate skewness? The direction of spread from center. Good. Direction of spread from center. From the center towards which direction you have the spread? Do you have the long tail towards your left side, left hand side or right hand side? We'll discuss this. I'll show you the plot. So towards the left hand side, do you have the tail, or towards the right hand side you have the tail? So this actually, the information about these tails, the direction of spread from the center will be given by skewness measure. What is the formula for skewness measure? What is the formula for skewness? The different types of skewness we have is negative skewness, positive skewness, good, and we also have no skewness, no skewed data. Okay, so I'll talk about all this, right? Skewness is given as expected value of x minus mu by sigma raised to the power 3. Good. Where mu is representing mean, sigma is representing standard deviation. What is E representing? Expected value. Okay, this is not summation. Don't get confused. This is expected value. So x minus mu by sigma raised to the power 3. Okay, so now let me show you some. Okay, before I show you the plots, can you tell me the Python functions, that are used to calculate all these measures? For mean, what is the function that I have used for calculating mean value? What function did we use? Mean. It's mean only, friends. Yes, mean. Mean is the function. For median, it is median only. Right? Then mode, it's mode again. Mean, median, mode. Okay? Yes. Right. What function did we use for variance? For calculating variance in Python? Which function did we use for calculating variance? Var, VAR, that's it. Var, good. Standard deviation, what function did we use for standard deviation? STD, STD, STD is the function. I'm asking about functions, friend. Okay, so which function did we use for calculating standard deviation? It is STD. Okay, what function did we use for calculating range of our data? It is STD, not STDV. No, max minus min. Max minus min. Okay, don't get confused. The range function that we have discussed earlier is not the function that does the same with respect to calculating range of our data. For getting the range of the data, we are supposed to use maximum minus minimum. This logic has to be used, and to get the range of our data. Max function will calculate the maximum value of the data. Min function will calculate the minimum value of the data. Good. Then, what about skewness? Skewness. Skew is the function. Okay, scheme is the function, right? So all these, 7 measures were being discussed, but let me show you some plots before we start and discuss fourth moment business decision. Okay, Right. So, as part of third moment business decision, okay, let me keep like this. Yes. So, as part of third moment business decision, what did we discuss? We discussed that third moment business decision talks about the direction of spread from the center. What is the center? Center is nothing but median, friends. You take any data, the middlemost value will be the median, right? What is mean? Mean is nothing but average, right? But average also should be at the center, right? Why it is getting influenced? In case A and case C, in plot 1 and plot 3, mean is getting influenced. It's getting pulled, right? Because of extreme values in A and C cases. Okay, if you take mode is nothing but most repeated value. That most repeated value is nothing but the highest peak. Whatever the value which has more number of repeated, which gets more number of repeated times in the data, that will be the mode. So obviously the peak will be the mode, right? So if all of these three are same, mean, median, and mode, that means it is normally distributed data, nothing but no skewed data. Okay, but whereas if what is the relation for negatively skewed data? What is the relation for negatively skewed data? Because of outliers in negatively skewed data, if you observe properly in this plot, there are some outliers at this position. Okay, because of that mean which has to be initially at the center, it's actually getting pulled, it is getting influenced. Okay, so that is the reason mean is getting influenced towards the outliers. In the same way, which has to be mean, which has to be here, I have outliers towards my right hand side. So mean is getting pulled towards right hand side. The long tail is actually representing your outliers. There might be outliers in the data. So that is actually representing the outliers. These outliers are actually pulling the mean towards them. So what is the relation with respect to mean, median, and mode for negatively skewed data? Come on, friends. What kind of relation can you draw here? Mean, median, mode. What kind of relation does mean, median, and mode have for negatively skewed data, also called as left skewed data? Good. Mode greater than, median greater than mean. Also nothing but mean, sorry, yep, mode is greater than median greater than mean. This is nothing but, can I write like this? Mode greater than, median greater than mean. I can also read it as mean less than, median less than mode. Yes. For no skewed data or normally distributed data, mean will be equals to, median will be equals to mode. All of these three will lie at the center. Why? There are no outliers. Since there are no outliers, since there are no extreme values, I don't see any kind of tail. Because there is no tail, mean does not get influenced. Median, which is actually in the middle position, will lie at the middle, which lies at the middlemost position only. Mode, which is actually representing the peak will also come at the middle position. So all of these three will be at the middle position of the plot. Whereas for positively skewed data, which is also called as right skewed data, what is the relation, friends? Mean is greater than, median greater than, mode. So this is opposite to negatively skewed data. That is the difference. I hope you understood, friends. But if you understood the logic, okay, if you understood these, visualizations, how to get these visualizations, we'll discuss. But if you understood the three types, negatively skewed data, no skewed data, positively skewed data, okay, EDA, it's done. Because only one thing that we have left out is fourth moment. We'll talk about fourth moment also. Okay, so by just knowing mean, median, and mode, can we comment on skewness or not? Question for all of you is, I know the values of mean, median, and mode. Can I comment on skewness or not? That's it. Is it possible? Yes, we can. We can comment. So I'll again we'll do the exercise one more time. I'll run the code one more time during the hands-on phase. You guys are supposed to tell me what kind of skewness does each and every column have. Okay, so just remember these, you know, relationships. We can comment. Yes, good. Right. I hope it's clear now. Third moment business decision. It talks about the direction of spread from the center. From the center, do you have more spread towards your right hand side or left hand side? In this case, more on left hand side. So if I take this as the center, this is nothing but the center. I see a long tail towards left side. This is representing negatively skewed data. And if I go to the phase plot 3, I take the center. From the center, I see more, the long tail towards the spread more towards right hand side. So this is nothing but positively skewed data. Okay, so just remember these, relationships. That's it. Done. Now, the fourth moment. Yes. Any questions so far? Can I proceed to the fourth moment business decision? In both the diagrams contain mode as high. How can we? I did not get you. In both diagrams, which diagrams you are talking about? These one, two, three. How can mean? So can you think mean later? Yeah, that's what my friend see. In these three okay, let me talk about A and C. Okay, so if we assume it as the center value, assume it as 0, since it is towards the left hand side of 0, mean is getting pulled towards outliers, right? Because I have outliers towards my left hand side. So obviously, you know, uh, mode being the most repeated value, the relation will be like mode greater than, median greater than, mean. Just assume it as a tip. Assume that median as 0. Towards the left side of 0 will have negative values, and towards the right side of the 0 will have positive values. Right? In that way, you can remember the relationship. I hope the same thing holds here as well. So mean greater than, median greater than, mode. Is it clear? Mode is nothing but the most repeated value. Obviously, in this entire plot, where do you see the highest tall peak? Mode means what? A value which is repeating for n number of times, the highest number of times. Obviously, that is nothing but this value. This is the value which is repeating for more number of times. So that is the reason we see a tall peak, right? Yep. Skewness is used for outlier detection partially but not completely. It see, I did not tell that there are outliers. There might be presence of outliers, and because of the presence of outliers, we see a long tail towards the left hand side. In the same way, there might be presence of outliers towards our right hand side. So I see an long tail towards my right hand side, but we cannot blindly tell that there are outliers in this data. It's not possible until unless there is a visualization. We'll talk about it. So only after visualizing such kind of plot we can comment on outliers, but here we are not sure. There might be presence of outliers. I'm telling, right? There might be presence of outliers. Right. So let's get started. No, the next moment, it is fourth moment, business decision. Okay, fourth moment, business decision. What does this fourth moment business decision talk about? First moment is talking about the center value. It's giving the information about the center value. Second moment, it's talking about the spread from the center. Third moment, it's talking about the direction of spread from the center. And fourth moment, it talks about, or it is a measure of peakedness. Here, if you observe properly, there are in total three graphs. One, this is two, and this is three. Fourth moment talks about measure of peakedness. Peakedness. What is this peakedness? It's nothing but it's talking about the peak. Oh my god, what is this peak? Okay, let us understand. So, as part of fourth moment, we calculate a measure called kurtosis. It is kurtosis, friends. So, kurtosis has formula, and let me keep it over here. It is expected value of x minus mu by sigma raised to the power 4. If it is 3, it is skewness. If it is 4, it is kurtosis. The same formula, if the power is 3, it is skewness. We are calculating skewness. If the power is 4, it is nothing but kurtosis. Okay. So what exactly this kurtosis talk about? It talks about the peakedness. Like how skewness is of three types: positive skewed, negative skewed, no skewed. In the same way, kurtosis is also three types: negative kurtosis, positive kurtosis, and zero kurtosis. What is this positive, negative, and zero kurtosis? Let us talk about these three plots. Okay, these three forms. Positive kurtosis is nothing but it's a plot, it's a form in which we have the peak as very high, it's very tall. A tall peak is what you observe in your data with long tails. See, if you observe positive kurtosis peak, this graph, you observe the peak, how big it is. We'll get a tall peak with long tails. Okay, so that is nothing but positive kurtosis. Whereas Negative kurtosis is nothing but you'll get a wide peak. See, it's wide. Is it sharp like positive? No. Whereas you'll get a wide peak with no tails. No, in the sense, compared to positive kurtosis, the tails will be small. Then we'll have mesokurtic, nothing but no kurtosis, normally distributed data, where uh, the kurtosis value will be exactly 0. Okay, so what is this representing? This is representing standard bell curve. The standard bell curve that we get general, it is nothing but mesokurtic plot. So positive kurtosis curve is named as leptokurtic, negative kurtosis curve is named as platykurtic, and zero kurtosis curve is named as mesokurtic. Okay, so the value of standard bell curve, kurtosis value of standard bell curve is 3. Okay, so this is again -3, which is representing excess kurtosis, friends. So these 3 that you have in the formula is nothing but the actual value of standard bell curve, the kurtosis value of standard bell curve. And if the difference between these two, if it is a positive number, it is nothing but leptokurtic. You'll get a tall peak, a sharp peak with long tails. What if the difference between these two is negative? If it is negative, you'll get a wide peak with no tails. Okay. What if the difference between these two is 0? If it is 0, you get exactly a standard curve, a bell curve. That is representing mesokurtic. So leptokurtic, mesokurtic, platykurtic. Positive, 0 and negative kurtosis. Is it clear? Yes. So Akhil, as part of the hands-on, I just observed that we are calculating skewness, we are calculating kurtosis, but are we visualizing anything? So far, no, friends. I did not tell anything about visualizations, right? So we'll start visualizing once if all these movements get completed. For time being, we are just measuring, we are understanding how to calculate these measures, 8 measures presenting 4 moments. I'll repeat it one more time. See, kurtosis. Okay, let me be from the basic. First moment, what it is capturing, the center value, the representative value, yes. Second moment, it's talking about the spread from center, yes. Third moment, it's talking about the direction of spread from center. Direction of spread from the center. Okay. What about fourth moment? Fourth moment, it's talking about or it's measuring peakedness. See, if you understand these 4 moments when you are trying to, you know, do analysis on the data, first of all, you have to understand um, each and every column, right? What is the center value that is representing the column, the data that can be given by first moment? What is second, third, and fourth giving together collectively? What are these 3 giving in collectively? These 3 moments, second moment, third moment, and fourth moment, they are actually talking about distribution of your data. Observe properly. Are they talking about distribution? Yes. Spread from the center, direction of spread from the center, peakedness of your distribution. What does these three see? If you observe this plot, you tell me if this is your center, towards which side you have majority of your data lying. Where do you have majority of your data? Obviously this side, in my right hand side. Why? I see a big, I see a tall peak. A majority of my data is towards right hand side, but why there is a long tail? Might be there is an outlier here, so because of one outlier I see a long tail. But are you sure that there is data here? I'm not sure. I hope you are understanding, friends. I'll take an example. I'll take a company. There is an organization ABC. Okay, and in this ABC organization, I'll take all the salaries of the employees, right? So there are 100 employees, and out of 100 employees, how many CEOs can you have? One CEO? Obviously there will be only one CEO, right? One chief executive officer, right? So what will be the salary of one CEO? Very huge. Yes. Compared to the rest of the 99 people, these 99 people, if I compare with this salary of one CEO, will it be huge, or will it be close to them? It will be very high. Assume that average salary of these employees, 99 employees, is around 40,000. Assume. But this person itself will be paid around, 2 LP, 2 lakhs or 3 lakhs. So if I plot the data using a plot, okay, so that CEO will lie here, because the salary of the CEO is very high. But what about the rest? Majority of them, they lie beyond this average only. So where is my large amount of data is residing? In this left hand side. But why there is a long tail? Because of one person. This person's salary is very high, and because of that, I see a long tail. And this person is actually influencing mean, average. Because of this one person, the mean from the center gets pulled, because very high salary, right? So this high salary is contributing more to the average value. The same example that we have discussed, 1, 2, 3, 4, 50. Instead of 1, 2, 3, 4, 5, where the mean is 3, if I have an extreme value like 50, my mean gets, you know, it becomes 12. So see the variation from 3 to 12, how there is a change. Okay, let's not get into that zone. We'll talk about the use cases when we do hands-on. But yes, right. So these three moments in together, they are talking about the distribution of data. Okay, these two talk about the first, second moment talks about the spread from the center, but it's not talking about the direction towards which direction there is more spread. It's not talking about the direction. Whereas third moment is talking about the direction. Okay, where are the extreme values, towards left hand side or right hand side, or there is no kind of outlier. There is no kind of if there is no extreme value, obviously all of these three will lie at the center. Then comes the fourth moment. In your data, is it going to give a sharp peak curve or a wide peak curve? Okay, that is actually measured by fourth moment, peakedness, measure of peakedness. Okay, if you get a sharp peak, it is nothing but positive kurtosis. You'll get a positive value for kurtosis. If you get a wide peak, you'll get negative value for kurtosis. What if you get zero? It is nothing but standard normal curve, normally distributed data, similar to this. Okay, taking this as reference, we can tell this is positive, this is negative. Obviously, you should have something reference. If I draw a line and I'll ask you, is this line big or is this line tall? How can you tell that? Obviously, you should have some reference. If there is a reference, by comparing to the reference, then you can comment. Yes, this line that I have in case 1 is actually tall compared to case 2. What about the line that I have in case 3? Is it big? Now tell me, compare. No, it is small compared to case 3. So in that way, my standard normally distributed curve, which is nothing but the same, where the mean, median, mode will be same. Taking that as reference, I can tell whether it's a sharp peak or wide peak. Okay, so this was explained by kurtosis. And the formula for kurtosis is expected value of x minus mu by sigma raised to the power 4 minus 3. Why do we have minus 3? This minus 3 is representing the kurtosis value of the normally distributed curve. Here is the point. You are taking the reference, right? So you are supposed to remove it. This value, whatever you get, subtract that value from 3. Again, if you get a positive value, that means you'll get a sharp peak, tall peak with long tails. And if you get a negative value, you'll get a wide peak with no tails. So that is the clear explanation for kurtosis. Is it clear now? Shall I proceed to the hands-on? Or do you have still any kind of questions? Come on, friends. Any questions? Or should I continue? Right? So let's get started with the same use case. We are left out with the fourth moment, right? Yes, see, there is no change with respect to the commands, first of all. Whatever the IDE that I'm using is Spider. You can use any other IDE. But if you ask me what is your choice or what is the good IDE, what is the best IDE for freshers who is not having any kind of exposure to Python, my answer would be Spider. Okay, the commands will be same. Okay, you can use these commands as is in any other IDE. Right. So I'm importing pandas. Okay, then reading the data from a CSV file, the same data friends. Okay, so I'm just calculating mean using mean function, and I'm doing it over sepal and column. It is 5.84. Now on the same column, let me go and calculate median. It is 5.8. Then on the same column, I'll also calculate mode. It is 5. So by understanding these three values, what can you comment with respect to skewness? 5.8 is the mean, 84 is the mean, 5.8 is for median, 5 is for mode. What kind of skewness does sepal length column have? Okay. From the drive, it's obviously you are supposed to download the data, my friend. See, whatever the data sets that I'm using, all of them are publicly available. Okay, so like go to Kaggle and get the data set of iris. Okay, you can download it and use it. It will be negative skewness or positive skewness. 5.84 greater than 5.8 greater than 5. So obviously I should get a positive value for my skewness for sepal length. But this will be very close to 0. Why? It is almost, you know, normally distributed, but there is a slight variation towards positive side. It cannot be negative, my friends. That's what I'm telling you. Focus on the relationships. It cannot be negative. It should be positive. Let me do one thing. Petal with right. Okay. Or let me do one thing. Here itself I'll change settle with. Let me ask you, or let us do it one more time, but this time let us go with sepal width column. So I'm going to calculate mean for sepal width 3.05, median for sepal width 3, then mode for sepal width 3. So what kind of skewness does sepal width have? Will it be positive, negative, or what? Will it be positive, negative, or as all the values are nearby, obviously it will be no skewed, but we are not sure because if you see there is a slight variation. 3.05, obviously 3.0, here also it is 3.0, here also it is 3.0. So the value of skewness should be very close to 0 if I go and calculate for sepal width. Okay, so let us check 0.3, right? Yes. Now let us calculate fourth moment business decision. For that, I am going to use a function called cut. I am printing fourth moment business decision to the console. Yes, positive. Yes. Then printing kurtosis to the console. Now I am calculating kurtosis for sepal length column. Okay. What is the syntax? Data frame dot column name dot cut function. So tell me what kind of kurtosis it is. It belongs to minus 0.5520. Is it positive kurtosis, negative kurtosis, or what? It belongs to negative kurtosis. It is negative kurtosis. So what kind of plot you can identify for sepal length? Will it be sharp peak and long tails or wide peak with no tails? Will it be with sharp peak? Negative kurtosis is the answer, right? So with respect to the visualization, what kind of peak can we observe? For negative kurtosis, it is wide peak. Good. We observe a wide peak with no tails. Wide peak. Okay. So this one. No, 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 no. Sharp peak is for positive kurtosis, right? So since we got a negative value for kurtosis, obviously you should get a wide peak. You'll get a wide peak with no tails. Okay. Then let me also calculate kurtosis for sepal width. Comment, is it positive or negative? Is it representing positive kurtosis or negative kurtosis? For sepal width, positive. So you should get long tails with long peak or wide peak with no tails. It's representing positive kurtosis. Okay, with respect to visualization, what kind of peak you'll observe? Sharp peak or wide peak? We'll observe a sharp peak with long tails. Long peak with long tails. Good. I hope it's making sense. Okay. So this marks the end of EDA. I mean, with respect to movements, we did not complete visualization, but when someone asks you to perform EDA, this is the actual process, friends. Okay, so first understand the data characteristics, then try to uh, load the data into the IDE, whatever it you are using, and start working on uh, first movement, second movement, third movement, and fourth movement. Right? Good. Now, let us go and understand the data visualization that we are actually very interested in. Okay, so what do you mean by visualization? Can someone tell me what do you mean by visualization? What is visualization? Come on, friends. What is a visualization? Visualization is nothing but pictorially representing your data. Okay, whatever it might be. Okay, so I have data and I want to represent into in a picture. That is nothing but yes, visualization. Representation of data in the form of graphs. Representing data. Okay, everything is accepted. Right, sure. Okay, so what happens is under visualization, you'll try to understand the data more. Okay, so even though if you perform EDA, it's better if you visualize the data, the raw data, and get the insights. So these visualizations are of generally basically two types: univariate and bivariate. Yes. What do you mean by univariate and bivariate visualizations? Come on, friends. What is the meaning of univariate visualization and bivariate visualization? We discussed this word univariate. Univariate is nothing but, you know, visualizing one column at a time. Am I right? See, in my data, I have n number of columns. Okay, you take one column at a time out of these n and visualize the data which is present in this one column. Right? So this is nothing but univariate visualizations. What is the meaning of bivariate then? Uh, yes. So visualizing two columns at a time. Okay. So instead of using or instead of visualizing one column, you know, we'll take two columns at a time and then we'll visualize. Such kind of visualizations are called bivariate visualizations, bivariate plots. Can you give me some examples for univariate plots, univariate visualizations? That's the question that I have. So, give me some examples for univariate visualizations that we are using from our school days. This is not a new topic, guys. From our school days, we are learning univariate visualizations. Just give some, try to give some examples. Density estimation. Okay. Have you ever heard about bar plot, histogram? So, under univariate, we are going to learn bar plot, histogram, box plot. What are these three? These three are univariate visualizations. Univariate visualizations are nothing but visualizing one column data at a time. Then, under bivariate plots, we are going to learn an important plot called scatter plot. Okay, it is nothing but scatter plot. Right. So let us understand what is this bar plot, histogram, box plot, then scatter plot. We'll go with hands-on. I think it will be very interesting because we are going to visualize the data using Python as part of EDA. So focus. We'll try to understand few plots today, then few on the next day, and we'll run the code for all these plots by taking use cases. Right. The first plot is bar plot. What do you mean by bar plot? Bar plot is nothing but it's a plot, it's a visualization in which you are representing the data using bars. See, each one that you see here is a bar. All these are bars. Okay, so whatever the visualization that you are seeing is with respect to year of car release. So this is related to an automobile company or automobile organization. Depending on the year, okay, they have released on an average. What is its MPG, miles per gallon? Nothing but mileage. You are seeing it on the y-axis. Okay, so bar plot is nothing but it's a plot in which the data is represented using bars, vertical bars. Okay, can someone tell me what is the disadvantage of using bar plot? No, friend. See, don't assume bar plot as a bivariate plot. Majority of our friends will get the same question. Akhil, you see here, this is a bar plot in which I have x-axis and y-axis. Am I right? That's what majority of the folks have the question. Hmm. See, in general, you are this diagram, whatever you are seeing, with is the drawn with respect to Power BI. It's a visualization tool which helps us to visualize the data in clear, right? So here I actually took two columns, but in general, bar plot is a univariate column where the data will be taken on one axis. nothing but x-axis, and by default y has the frequency, the count. Okay, it's not a bivariate plot, it's only a single univariate plot. Don't get confused. On x-axis you'll take your column, what is your column that you are actually working on, and by default y-axis will have frequency, the count. Okay, so but in general bar plot is not a good visualization. Why? The reason is bar plot is not an ideal plot for large data. Why? What might be the reason? The reason is it's very simple. When you have more number of rows, okay, when you have more number of records, these bars that you actually have gets congested and gets converted to lines, one after the other, one after the other. So they get adjusted in such a way the bars get squeezed and converted to lines. Because they become lines, it becomes highly impossible to interpret such kind of visualizations. We can't interpret anything from such kind of visualizations. Okay, so then comes the histogram into the picture. Same plot, but instead of having the values, it tries to convert the values into bins. We actually group the values in histogram. Okay, so we'll try to take a column. What column did I take? Age. Age is the column. And did I take each and every age? No. Instead of taking each and every age, what did I do? I made a bin from 20 till 30. Okay, 30 till 40 is the next bin. 40 to 50 is the bin. In this way, I have bins till 100. Is it a univariate plot? Yes. Frequency. Is it another column? No. The only column that I have in this histogram is age, and by default, y-axis will take frequency, which represents how many folks fall under this bin. Second bin, third bin, fourth bin, so on. Okay, so one thing, friends, that you have to understand is histogram actually talks about your distribution. The data distribution, the histogram is talking about the data distribution. Okay, so if you observe, I'll just try to connect all the top positions of the bins. So this is how it is. See, it is talking about the distribution of the data, and it also talks about the outliers or extreme values. Outliers are extreme values. So, Akhil, are you sure that it talks about extreme values? Yes, it just talks about extreme values, but we are not confident that this 100 is an outlier or not. There might be chance of this 100 being an outlier, but are we sure? No. The primary objective of understanding or visualizing histogram is it talks about data distribution. This is the main purpose of visualizing histogram. Whereas the secondary purpose of visualizing histogram is it also talks about outlier values, but not sure. It just talks about it, probability. There might be chance of presence of outliers. Okay, might be 90, might be an outlier or not. We are not sure. But there is a chance of 90 being an outlier. That is what I'm trying to see. Okay, so don't get confused. Bar plot has a disadvantage. It's nothing but, it's not an ideal plot for large data, but for small data, yes. But in general, nowadays, Can you observe small data in any any of the place? Impossible, right? So the only data that is being generated is large data. So in order to understand the distribution of such kind of large data, histogram will actually make sense. Histogram is used for understanding data distribution, as well as it also talks about the presence of outliers, right? Yes. Then comes the third univariate plot, box plot. What is this box plot? Box plot is also called as box and whisker plot. Whisker plot, friends. Okay. So it is also called as whisker plot, also called as box and whisker plot, nothing but box plot. All of these three same. What are these? What is a box plot? A box plot is used to, it is used for it is visualized to talk about outliers. The primary purpose of visualizing box plot is it talks about outliers. Okay, so then what is the secondary objective of visualizing box plot? Box plot, it also talks about data distribution. It also talks about data distribution. So let us understand what is this box plot. Box plot was named as box plot because of there is a box in the box plot. Okay, so it is also called as box and whisker plot, right? So along with the box, you'll also have two whiskers. This is one whisker and this is the other whisker. Because of these whiskers and box, it is called as box and whisker plot as well, right? So how it helps us to talk about outliers? Because if you see here, the values that are beyond these limits, the circles that you observe in this plot are nothing but outliers. Oh my god. So actually it means box plot is very, mandatory that we have to learn. Yes, because box plot is the only plot which talks about or which visualizes the outliers information with confidence. Here, I may or may not, 100 may or may not be an outlier. You are not sure. Or 20 that you have in the extreme position may or may not be an outlier. But this talks with confidence. There are outliers. On what basis? If the values are greater than these limits, or if the values are less than these limits, those values are outliers. Okay, so first of all, what is an outlier? Outlier is nothing but extreme values. This is already discussed. Extreme values. Okay, so how are these limits calculated? Let us understand. When you take this box plot, toward the left hand side, you will have lower limit. This is lower limit. Okay, then followed by Q1. The starting position of the box is named as Q1. This position is Q1, which is 25th percentile. Okay, then the middle portion of the box, which is named as Q2, also called as median, which is called as 50th percentile. Then the last position of the box, which is termed as Q3, okay, also called as 75th percentile. Okay, then the final whisker, which is nothing but upper limit. How are these limits calculated? Lower limit and upper limit using some formulas. Okay, for calculating lower limit, I have the formula here. Q1, from Q1, You remove 1.5 times of IQR. What is IQR? Interquartile range. IQR is nothing but Q3 minus Q1. So this box that you see in the middle is nothing but IQR, interquartile range. Okay, so because of this interquartile range, you know, Q3 minus Q1, the difference between Q3 and Q1 will calculate IQR, and this IQR we can substitute in this formula, and this gives me lower limit. In the same way, upper limit is calculated using Q3. This is not minus, this is plus. Q3 plus 1.5 times of IQR. Okay, so that will result me in calculating upper limit. Okay, once if the limits got calculated, you can identify whether we have outliers in the data or not. Clear? So I'll explain one more time. As part of box plot, let us talk about the components of box plot. The first one is lower limit, then Q1, Q2, also called as median, then Q3, and finally upper limit. Okay, what is Q1, Q2, Q3? 25th, 50th, 75th percentile. What are these 25th, 50th, and 75th percentile? Okay, let me explain you the story. Assume that the data that you have is 100%. Whatever the data that I have, assume it as 100%. And this 100%, make it 4 parts. What will be the composition of each and every part? 25%. Yes. So this will be 25. This will be 25, 25, and 25. Okay. So IQR, interquartile range, this box alone will have 50% of your data. Then the right whisker will have 25% of the data. Left whisker will have 25% of the data. This is the assumption. If the data is normally distributed, this is the general assumption. Okay. So by taking these, you can calculate lower limit and upper limit. Q1 minus 1.5 times of IQR. For upper limit, it is Q3 plus 1.5 times of IQR. This will give me the lower limit and upper limit. Once if we calculate lower limit and upper limit, we can check, is there any value in the data which is less than the lower limit, or is there any value which is greater than the upper limit? And if we have such kind of values, those values are nothing but outliers. So box plot is the only plot in the entire data visualization which talks about outliers with confidence. This is an outlier. Yes, I can talk with confidence, or I can say that yes, I have outliers in my data by visualizing box plot. Okay, by just looking at other plots, we cannot comment the same. We are not that much 100% sure that whether it can be an outlier or not. So that makes the difference, my friend. Okay, so the purpose of box plot is, the primary objective is to talk about outliers, whether there are presence of outliers or not. Whereas the secondary objective of box plot is, it also talks about the data distribution. Is the data distributed normally, or is the data not normal? How can it be understood is, you observe the boxes. If these boxes are identical to each other, and if these whiskers are also identical to each other, then you can say data is normally distributed. If you see there is any change with respect to boxes and whiskers, yes, obviously data is not normally distributed. Let us understand all these points when we go and do hands-on with respect to the code. Okay, we'll take use cases and run the code. Right, I'll stop the day here. And if you have any kind of questions, yes, it's over to you. Any questions? The link has been provided. Please fill the form. And before you leave, if you feel these sessions are really amazing, share across multiple channels, multiple groups, and ask your friends to join these sessions, make use of these sessions. But before you leave, the friends, hit on the thumbs up button, just give a like, and always provide your feedback in the comment section. Okay. Yes, any questions? Right. If sure. I'll do it one more time. But let us take a use case and do it. I'll do it parallelly. No worries. I'll do it again. No worries. Yes. If no questions, thank you so much for joining the class. Right. Have a great day, friends. Bye. Signing off.